In this 14th podcast, we're going to be looking at acids, bases, and acid-base reactions, what happens when acids and bases are mixed. Now, acids and bases are basically aqueous solutions of certain ionic compounds. What that means is we take certain ionic compounds, we dissolve them in water, that's where the word aqueous comes in, and we make a solution. The ionic compound dissolves and we're left with an acid or a base. Certain ionic compounds. Let's take a look at acids first. So acids, ionic compounds that dissolve in water, and what happens is when they dissolve, hydrogen ions are liberated or released or freed up. In general terms, an acid can donate hydrogen ions in a chemical reaction. So in the acid, in the aqueous solution, there are free hydrogen ions, hydrogen atoms, if you like, which have donated, already lost their electron. Let's take a look at this picture here, this diagram. So this diagram here shows hydrogen chloride, HCl. When we add it to water, the hydrogen and the chlorine ions separate. We can look at it in that simple way, and we have the two free in the solution, and we can see the hydrogen ions are free. In reality, the hydrogen ions actually team up with the water molecules, but this view is a simpler view to understand. Now, bases are really just the opposite of acids. They are ionic compounds that, when dissolved in water, release ions that can actually accept the hydrogen ions, So acids can donate hydrogen ions or give hydrogen ions, supply them. Bases are in a position to accept hydrogen ions. So let's take a look at a base. So this base here, sodium hydroxide. Sodium hydroxide, when we add it to water, the sodium ions and the hydroxide ions, which are O and H atoms covalently bonded, they separate, and we can see that the OH can accept the hydrogen ions. Now, what will happen when the OH, the hydroxide ion, accepts a hydrogen ion? We will have an O and H accepting an H. What will happen in that situation? Keep that in mind. So as I've said, essentially acids and bases are opposites, let's say. Some examples of acids: we have HCl, hydrochloric acid, H2SO4, which is sulfuric acid, and HNO3, which is nitric acid. Some examples of bases: these would be strong bases at the top: sodium hydroxide, calcium hydroxide, and this one here, which we've seen before, sodium hydrogen carbonate, when dissolved in water, acts as a base. This is baking soda. And also many liquids found around the home are acids or bases. For example, vinegar contains acetic acid and is an acid, obviously, and a lot of cleaning products are bases. So because acids and bases are essentially opposites, when we add them together, they have a cancelling effect. It's like in math, if we add 2 to -2, they tend to cancel each other out. And in chemistry, when we add a base to an acid, they tend to neutralize one another. They act against one another. The reason is because in the acid, which has the hydrogen ions, and the base, which has the hydrogen ion acceptors, the base accepts the hydrogen ion, and the result is they cancel each other out. Let's take a look at this example here: sodium hydroxide and hydrochloric acid, two substances we've seen. Let's see what happens when we add them together. So sodium hydroxide in water we can see the sodium and the hydroxide ions. The hydroxide ions are able to accept hydrogen ions. Here's the hydrochloric acid. We can see the hydrogen ions and the chloride ions. We tip them all together. Obviously they all mix up. So in this example, the hydroxide ions team up with the hydrogen ions. Opposite charges attract, and the hydroxide teams up with the hydrogen and we get H2O. So during the neutralization process, the hydroxide and hydrogens team up together to make water. In the same reaction, the sodium ions team up with the chloride ions to make sodium chloride, which is table salt, the stuff we put on our food occasionally. So in the previous example, we were looking at a strong base, sodium hydroxide, and strong bases usually have hydroxide ions present, OH ions, but weak bases don't necessarily, but weak bases can still be hydrogen acceptors. Let's take a look at baking soda and hydrochloric acid. Again, it's a reaction which we've seen before. This is the baking soda, sodium hydrogen carbonate, hydrochloric acid, and we know that gives us sodium chloride, carbon dioxide and water. But in reality there's actually an intermediate step, and it's useful to look at that intermediate step to see precisely what's going on. So let's take a look at the ions first when these substances are dissolved in water. So we've got sodium hydrogen carbonate, which we have sodium ion and a bicarbonate ion. Sodium ion is a positive ion, it's donated an electron to the bicarbonate ion, so we can see that is a negative. And we've got hydrochloric acid, hydrogen ion and chloride ion. So these are all tipped together, and as you might guess, the sodium ion goes and teams up with the chloride ion because they're opposites, and the bicarbonate ion teams up with the hydrogen ion. Let's have a look and see what that makes. So we have the sodium ion, which teams up with the chloride ion, and the hydrogen ion, which teams up with the bicarbonate ion. So now we've got our salt, which was one of the products, and we have this thing here, which must be H2CO3, H2CO3. So you can see that the bicarbonate ion accepts the hydrogen ion, so it is by definition a base, because a base by definition is a hydrogen acceptor. So the result here, this is called carbonic acid, but carbonic acid isn't very stable, we could say, and it soon breaks down into water and carbon dioxide. So we can see here that the carbonic acid here turns into carbon dioxide and water. So in summary, acids are ionic compounds dissolved in water that release hydrogen ions. Bases are ionic compounds dissolved in water that release ions that can accept hydrogen ions. And when we mix the acids and bases together, the hydrogen ions and the ions that accept hydrogen ions tend to cancel one another out, and they produce water. And the most common example of that is hydrogen ion being accepted by hydroxide ion, and then we have H2O, water.